So welcome to the Global Network webinars. My name is Alexander Loschke and I'm moderating this webinar today together with my colleague Abdullah Ghosalev. Today we have with us Brendan O'Dowd from the Central Statistics Office, CSO of Ireland, who will talk about advancing AI capacity at the CSO for the production of official statistics. This is our fourth of 5 webinars in our AI for Official Statistics webinar series. This presentation will provide an overview of recent developments at the Central Statistics Office as it works to improve its AI maturity level through a range of initiatives. Central to this is the development of an AI strategy for the office, which will allow the CSO to scale their use of AI in a safe, effective, and coordinated manner. The strategy includes foundational principles which guide their approach and a new AI operating model which will provide clarity, transparency, and accountability in their use of AI. The presentation will also describe a selection of projects using AI which are ongoing at the CSO. Among these is their coordination or the coordination of a major ESSnet project involving 16 countries from the European Union, named AI and Machine Learning for Official Statistics. The objective of this 4-year project is to provide staff across the European Statistical System with a comprehensive suite of resources for implementing AI and machine learning. Finally, the presentation will cover some of the ways that the CSO builds awareness and skills in AI, including their annual AI week, which has a busy program of events, including generative AI hackathon for CSO staff. And let me say a few words also about Brendan. Brendan is the head of the Data Science Division at the Central Statistics Office of Ireland and project owner of the ESSnet project that I have mentioned. Brendan has a background in physics, having studied magnetic nanostructures for his PhD and has occupied a number of roles with the CSO since joining in 2016. And now, before I hand over to Brendan, just as always, some practical remarks. You can write your comments and questions into the meeting chat at any time, but during the Q&A session, we would really encourage you to ask your question yourself if you can. If you cannot, we can, of course, read them out. As always, this Global Network webinar is being recorded and will be made available on the Global Network of Data Officers and Statisticians on LinkedIn. And I have put already the link to join the Global Network into the meeting chat. So if you haven't joined yet, please do so, and please also sign up for our newsletter. And now over to you, Brendan. The floor is all yours. Thank you.
Thanks very much for the introduction, Alex, and thanks to you and the organizers for the invitation to present at this. I'm very excited to accept and to provide this update. So as Alex mentioned, I'm heading up the Data Science Division in the Central Statistics Office, the CSO in Ireland. And this is a bit of an overview of recent developments. So we'll get straight into it. There's 3 parts to this presentation. The first is on the development of an AI strategy for the office, which is still in development. And then I'll talk about some of the use cases of AI at the CSO, and then that ESSnet project, AI/ML for OS, AI and machine learning for official statistics. So we'll go into the AI strategy. Just on the right-hand side here, in these colored boxes, are some of the AI projects or projects involving the use of AI that have sprung up in the CSO in the last number of years. and they broadly group into three categories. There's sort of general purpose productivity applications. So we have a tool for translating SAS to R, different code assistants and Copilot chatbots. Then there's kind of corporate applications, which again are Gen AI and LLM based, but they're more bespoke or more specific applications, for example, around cybersecurity, training materials, or testing software. And then there's statistical production, which is a very large and varied area for AI. There's a lot of different use cases within that. Oh, well, there's several use cases within the CSO, but there's a huge amount of potential. So it's just interesting to kind of step back and consider those different categories. And in developing an AI strategy, I suppose when we talk about AI in statistics, it's very often the last category there. But in developing an AI strategy for the office, it has to cover all three. So a lot of these use cases developed in a slightly ad hoc manner over the last number of years based on skills and needs at local level. Um, the process was that we have an AI working group which review and approves or can decide to approve different proposals. But we decided that such was the pace of development in AI and that the increasing number of opportunities to apply AI that we needed a new AI strategy so we can scale our activities, have a more strategic, structured, and coordinated approach to our use of AI. And there's a lot of different stakeholders when talking about AI and governance. A lot of people need to be around the table, including technology, data science, cybersecurity, legal, governance, and different external stakeholders. So there a lot of different points of view have to be considered. So we began the process, I think it was around October of last year, and we got some outside help to start developing our strategy. Interviews were conducted with different heads of division in the CSO, and questionnaires were circulated, and an AI maturity assessment was carried out. And they have three categories of AI maturity, and they wanted to see where we were in the spectrum. So at the very beginning, labeled number one here, there's ad hoc AI, then there's defined AI, where you're kind of going beyond prototypes and moving into production. And there's optimized AI, where you're fully in production and you're able to, use lots of different data sources and tools. And they placed us at about a 1.4, which we kind of acknowledged as being probably about right. We had several different pilot projects, but there wasn't an awful lot at production grade just yet. But there was some interesting findings from it, or kind of my own reflections from that process. One was that I think that as an NSI, our principles are pretty well aligned to the appropriate and responsible use of AI. So some of the core values of the CSO, as I'm sure any NSI, would include quality, trust, and confidentiality. And those are really key considerations for responsible use of AI. So on reflection, I guess that there isn't a major cultural shift necessary, to start adopting AI or to make responsible use of AI. We the way, the culture, I think, is well aligned. You can imagine if the opposite was the case, that we had all the resources, but not the right attitude, that, it could very quickly spin out of control. So that's a positive. One other positive is that one of the areas that we scored highly on in the AI maturity assessment was around data. Our attitude and our approach to data was I think quite good, maybe compared to the other types of organizations that might be doing an AI maturity assessment. So we're quite expert at managing data, access to data, data security, and protecting confidentiality. So that's been a concern for NSIs for many years. So that sets us up well as well. And the last reflection I had was that in a lot of other organizations, other than NSIs, AI is often thought of in terms of generative AI, productivity, chatbots, automation, those kinds of angles. But within statistics, we're very concerned about or very interested in the use of AI for statistical production, and just can be hard to fit those use cases and that kind of thinking within broader conceptions of AI. So I just found that when, over the process of this maturity assessment and responding to other surveys about AI use in your organization, that a lot of the use cases that we have don't seem to fit neatly into other conceptualizations of AI. But that's just my own reflection. So in the strategy, then there's about six different components. And I'll just give a very quick overview of those now. So there's the vision, which started off very long, and then we gradually reduced it back down to this sentence. I should say as well that this is all still in draft form and hasn't been published yet, but the draft version of our vision is that it is to responsibly and safely harness. So there's an immediate emphasis on responsibility and safety. Harness AI to empower our people to enhance efficiency and to drive innovation. So there's the idea of being innovative, but also to enhance efficiency so that there's a kind of a focus on application and on business need. And that's kind of reflected in the strategic objectives that we've outlined as well. So the first of those is to exploit AI to generate business value. So it's about providing real business value, some kind of real meaningful results that's of benefit to the organization. We also want to establish an AI governance framework to upgrade or update how we manage AI. We want to build a workforce capacity and skills in AI, and we want to enable experimentation and innovation as well to create some kind of a sandbox and let people become familiar with these tools. But there is a trade-off in, I suppose, in that one, in experimentation and having governance, and it's finding the right balance is quite interesting as well. Then there's 6 principles that underpin how we approach AI, and any decision, I suppose, that is made around AI has to come back to these principles. So there's trust, quality, transparency, and fairness, governance and ethics, human oversight and accountability, so that there's an accountable person behind every decision or data set or figure, and that there's, where possible, human in the loop rather than full automation. Agile adaptation, so that we're able to adapt to new developments in AI, or challenges indeed. And then robust technical solutions, so the idea that we have the appropriate architecture for the kinds of tasks that we want to approach. And then there's 5 strategic pillars, and this part of the strategy forms the bulk of the strategy. So most of the strategy document is a description of what we're going to do under each of these strategic pillars. And the first two are closely related. That's governance and organization, how we're going to structure ourselves and what kind of processes we're going to have to manage AI. Our approach to people is the third one. Data is the fourth one, and then technology and the infrastructure is the last one. I should say on data as well that when I said that we're expert on data and managing data, it's not that our data is fully AI ready. It's we still have a kind of a taxonomy or labeling task ahead of us to enable that. But I suppose just in terms of our language and our approach and our attitude to data and some of the practices that we have built up over the years, I think will make that challenge a little bit more approachable. And sorry, just to say as well that there's some use cases that have been identified, things that we think are worth going after in the coming years, and a roadmap so that we can communicate, I suppose, firstly to ourselves where we want to be and how we're going to get there. Okay, and there's a question in there that I'll get to towards the end of the presentation. So this is our new governance framework. And again, it's in draft mode. There's an approval board layer, which would do the governance and the approvals, and then the strategic oversight aspect of it as well. There will be different boards involved, such as our confidentiality and data security committee and the cyber governance board. We're not yet sure if we'll have a standalone AI board, but the point is that decisions on AI need to be made at board level. And then what we decided is that we would have a separate enablement layer or enablement group to turn those priorities into, to implement them as into practice. And two of the things that this group would do would be to evaluate and assess proposals for AI use cases that would be then passed on to board level for approval. And they would also produce a catalog or an inventory of AI use cases for the office to promote transparency. Then we would like to have a community of practice, and this is really about ideation and experimentation, for knowledge exchange and to develop skills. And that the whole thing would be underpinned then by organization-wide training and development and communications and awareness. Okay, so that's the draft governance structure for ourselves. And then the benefits that we hope to realize from all of this is that we'd have good governance of AI, and we'll be able to demonstrate that. We'd have good clarity about what it is we're interested in doing with AI and for ourselves and making decisions around AI. We hope that it would be an adaptive framework, that it would provide strategic alignment so that the kinds of activities that we're engaged in with AI are actually linked to some high level objective of the office or some business need. and then that we have a roadmap for implementation. So again, like I just said, that we communicate in the first place to ourselves where we're going and how we're going to get there. So now this is the second part of the presentation. This is on a handful of projects in the CSO that involve the use of AI. And there's been quite a few, but these are ones that are more closely linked to my own division in data science. So I'll talk a little bit about our work on text classification. I'll talk a little bit about peatland mapping, and then an area that we hope to get into in the coming months, which is document analysis. I've less to say about that, but I'd like to flag it anyway. So just a word about the data science division is that one of the key aims or activities for the division is what we call strategic production support. So we're supporting other business areas in the office to modernize their processes, to improve the quality, to improve efficiency. We're not or less interested in developing new standalone outputs. So we're trying to be more integrated with business areas in the office. Um, and we want to work in a collaborative way with other business areas for two reasons. Number one, because I think that any good project in this area relies on both kind of a technical expertise around whether it's data science or AI, and the business area knowledge as well, I think is key to making success of any kind of a project. The other reason we prefer to work in a collaborative approach is for knowledge exchange, that we kind of upskill the business areas that we're working with over the course of the project, and also that we're able to hand it over to them at the end so that we can free ourselves up to work on something else, that they're then upskilled such that they can maintain whatever the solution is. We are a small team. We can't pursue every single part of data science or AI. We can't boil the ocean. So what we try to do is focus on specific skill domains that we think are highly transferable. So we looked around the office at the different needs and the different activities, the different kind of burdensome things that were going on, and we looked around Europe at different projects and different uses of what other data science divisions were doing. And out of that text analysis and the whole area of text data kind of emerged as a nice area for us to get involved in. It's a domain that we think has applicability across a lot of different business areas. And if we were to develop expertise in this, it would be reapplicable again and again. And I suppose there's two benefits that they're kind of saying the same thing. One is about untapping the latent value of existing data. So there's a lot of existing or historical data that's out there, which has a huge potential for statistical production, but is lying idle. So there's that aspect. And there's also new data sources. So the kinds of data that people haven't looked at all before, um, that can be repurposed for statistics. So out of that then came this work around text classification. And one of the first areas that we became involved with was around cause of death classification. So I'll talk a little bit about our work in this area around trying to classify text data from death certificates. And I think the best place to start is with a description of a death certificate itself. So this is what it looks like. The structure is usually quite similar, no matter in a lot of different countries anyway. One of the main parts is this area here, cause of death, which has a number of rectangles underneath. And what this is, it's a causal chain of events, starting with the most immediate or direct cause of death, and then sequentially listing any preceding conditions or causes as you go down. In theory, then, this ends with what's called the underlying cause of death, or the UCOD. So that's very important for statistical analysis, is the UCOD, the underlying cause of death. All of the strings, no matter how many of them are there, they all have to be classified, but the last one is key. It's not the UCOD, or the underlying cause of death is not always the last string in the sequence, and it might have to be determined in some other way. There's also a column there for the time interval for the duration of the condition or the cause, and with both of those columns, there isn't a massive degree of standardization. So the physician who fills it out has a lot of freedom in how they fill this out. Now we do get digital copies, so we don't have to carry out OCR, we don't have to do handwriting recognition on these anymore. But there's still a lot of freedom which has to be make standardization and classification difficult. So there are 35,000 deaths in Ireland each year. This is just to put some numbers on this. They include 80,000 narrative strings, all of which have to be classified. In the case of just over half of certificates, there is a piece of software which can automatically classify them. This is called Iris. It's Eurostat approved. It's a standard internationally used death coding software. And as I said, in the case of Ireland, it works in just about over half of cases. So the remaining 45% have to be manually classified, which is a fairly time-consuming process. And I'd like to talk a little bit about why it's so difficult. Why is this manual task so challenging? There's a number of reasons. As I alluded to a moment ago, there's a lot of variation in how the narratives are written. They can be overly wordy. There can be a lot of superfluous text. The language is extremely technical. It's very niche. The words don't appear in standard dictionaries. There's a lot of misspellings in there. One example is a very common term called atrial fibrillation, or AFib. And in the space of a few years of data, we found 40 unique spellings of the term atrial fibrillation. So just that one term can produce 40 different spellings, gives you an idea of the scale of the challenge. As I said, with time intervals, it's non-standardized in how those are written. Punctuation and different kinds of formatting can prevent Iris from doing its automatic classification. And there's about 8,000 codes. So the standardized classification here is ICD-10, and it's extremely detailed. So on the right-hand side is just an example of C00, malignant neoplasm of the lip. So there's 10 different codes here, depending on whether it's the inside or the outside of the lip. And that excludes separate sections on malignant melanoma of the lip and basal cell carcinoma of the lip. So this isn't even the full set of, lip cancer classifications. It's extremely detailed. So what we did is we came up with two key interventions. The first is a customized text cleaning process, and the second is a classification assistant powered by machine learning, which provides the manual coders with suggested classifications. So we'll get into each of those. So the text cleaning then is, for spelling, we use this Hunspell package in R, which finds misspellings. So what we had to do was we had to develop our own medical dictionary, or a customized dictionary of terms from this corpus. And Hunspell is able to identify misspellings and suggest replacements based on the Levenshtein string distance is what we use. But we decided to introduce some kind of ranking into our algorithm to improve the quality of the replacements. So we prefer words from medical dictionaries over words from general dictionaries. We prefer words or rank more highly as replacements, words which appear more commonly in the corpus. We prefer words, or replacements, I should say, which are simple misspellings. So there's kinds of simple misspellings that humans would make that are very typical, like a double letter instead of a single, or vice versa. A missing or a present apostrophe are the case. So we rank those replacements more highly. And words which sound the same as the misspelled word. So we use the SoundX algorithm to create a phonetic pattern of the misspelled word and all of the potential replacements. And we prefer words which sound the same when spoken. We also fix punctuation and formatting, acronyms, and then the time intervals with this process. So these are just three examples of misspelled words and how the algorithm that I mentioned a moment ago finds appropriate replacements. So the word cannula had two replacements suggested, and the correct one, which is highlighted in yellow, was ranked more highly because it differed from the misspelled word by a double letter. So that was an example where it worked. And then Coronia was a misspelling, and again, the correct one, the two options were Corona and Baronia, and this one was preferred because it has a similar phonetic pattern. And then in this example, sheath was a misspelling, and there was, I think, 6 different potential replacements, and the correct replacement was identified because it came from a medical dictionary rather than a generic dictionary. So there's some examples of that in action. So the effect of all of this is that there was an improvement in the automated coding rate of about 10%. So from before, 55% of certs were automatically classified, and now it's about 65, which is about 4,000 certs per annum. So we're quite happy with that. The other intervention then is this application. So what it has is a machine learning pipeline that's developed with scikit-learn. We tried out a lot of different machine learning models, including logistic regression, random forest, and a few different gradient boosting models. It was trained and tested with about 200,000 certs. The model works in the background of this assistant that we built in R Shiny, and it provides the top 5 most likely codes for a selected piece of text. I should mention that the distribution of causes of death is very, very highly skewed. There's a large number that very rarely occur, and a machine learning model such as these is never going to be able to identify them from unseen text. So we have a different approach for those, which I'll describe in a moment. So the machine learning pipeline is that we start with the text data, we do a stratification, train and test on we do a feature extraction using a term frequency, inverse document frequency, and then label the targets. And then the machine learning pipeline assembly begins. There's nested cross-validation. We select the best model. It's retrained on the full training set. We do the final evaluation and then deploy it in our application. So just a very quick look at the pipeline. As I said, there's 5 suggested classifications, each from the machine learning model. And then we have another approach for the rarer cases, which is that it finds exact word matches between the input text and the labels of the classifications themselves. And that has proven pretty useful. It's designed to be used alongside Iris. So this application is designed to be integrated with the existing workflow. And there's a kind of a focus on reusability. So we try to develop it in a modular way that can be redeployed for other tasks. So I'm going to click on this link here and hopefully provide a demonstration of this. So this is some test data. And I should say as well that this is synthetic data. So we're not going to be looking at data from real individuals this morning. So first it does some cleaning on the text, and then we can go into batch view here. So what I've done is I've accessed a batch of certificates. There's 129 certificates in here. I can select any line in. So each, this window represents a single death certificate. I can click on one of the lines. So there's an ID key here, a line number, a code line. If it was automatically coded, this would be populated. It says rejected because Iris wasn't able to classify this certificate. And then there's the free text line. So you can click on one of those. It provides a machine learning model suggestion. You can click on the link there to open up the page on the World Health Organization website. It's a bit slow at loading this morning. And then this is the dictionary matches, or the word matches. So it finds words in the free text and looks for classifications which have some of those words. You can look at those as well. In some cases, there's a comma or a pipe in the free text, and that's an indication that it needs to split it into 2 chunks and classify each of those separately. And so you can cycle through the certificates and view the suggested classifications in each case. Or you can jump to a specific certificate, and you can also show the original text. This is cleaned text, and you can, if you doubt the quality of the text cleaning process, you can look at the original text and make your own decision there. So the apostrophe, for example, was dropped out of Alzheimer's in there. There's also a free text matcher, so you can experiment and type in some free text and see some suggested ICD-10 classifications there as well. So that is that. I'll go back to the presentation. I should mention at this stage that we had a visit to the ONS in the UK in summer of last year, and they had an ACE classification assistant, and it was a very informative visit, and we learned a lot from talking to them and the design of that application. So with a nod to the ONS for their, what's the word, inspiration. This is just a screenshot of that. And then we were kind of able to pivot this towards an ACE classification as well. So there's some statistical processes in the CSO that do manual classification of free text data on business activity. I hope that most people on the call are familiar with NACE. It's a standardized classification for enterprise activity. Yeah, so one of the, I suppose, the use cases in the CSO is OFAT's a survey of outward-facing affiliates. So that's one use case. It's based, as I said, in the previous work on the cause of death classification. And again, it presents suggested NACE codes to the manual coder based on the same 2 principles, the machine learning model or tokenized string matching. I just have a screenshot of that here. This is this is a screenshot of the assistant for NACE. It shows some free text being entered into that function of it, and the options there from the model and from the dictionary matches. One difference here is that what we've done is we've taken all of the classification labels. So, for example, down there, retail sale of beverages in specialized stores. And we've asked an LLM to add 50 related terms to that, just to kind of, if you can imagine, creating a larger runway to land on, so to increase the likelihood of having a relevant match between the free text and the classifications. So that's been working nicely for us. Some of the challenges that there's a lot of codes, not quite so many as ICD-10, but still a lot. Many of those, again, it's highly skewed. We don't have good training data for a lot of them. A lot of the training data is very short and ambiguous, much more so than the cause of death training data. More than half of all our data for training is 1 or 2 words in length. That's the length of the string. There's a lot of ambiguity. There's a lot of one-to-many cases. I think something on the order of 2/3 of all of the NACE codes include at least one enterprise whose description is subcontractor. So, for example, if somebody writes in subcontractor, it's almost impossible to generate the correct suggestion because it lives everywhere. So there's problems like that. But the benefits are that it can improve efficiency for manual coders. There's a lot of transferable skills in this project, which is good for us. We do need more training data. We have our eye on a couple of different sources, which will provide more nutritious training material for this model. How the tool is used in practice is really important, and who's using it. Is it a member of the public, or is it a trained person in the division in the CSO? So that's key. And I suppose it highlights the benefits of ensemble methods, of not just relying on a single tool or a single approach. I'm going to talk about one more use case in the CSO before going on to the document analysis in the one-stop shop. So this is about peatland mapping, and I've just one slide on peatland because I'm not sure how familiar people from these different organizations on today's call are with peat. But it's a type of wetland. Actually, there's 3 different subclassifications of mires, bogs, and fens. But the aggregate group that we're interested in here is peatlands. And what it is, it's a type of wetland, and it's formed by layers of partially decayed organic matter that's usually built up over many thousands of years. So this is an image of a bog in Ireland. This has been cut for turf. You can see mounds of turf there stacked around for drying. So it's a very important carbon store. It has historically been a very important source of fuel for electricity and heating. But it's also very important for biodiversity, and for it's an important habitat as well. So why are we talking about peatland? Well, there's an EU regulation from 2011 which says that environmental economic accounts have to be published every 3 years with extent accounts. So there's extent that's the amount of square kilometers or whatever the unit is of each type of land cover. And peatlands is the missing piece of the puzzle for us, or was. We were able to get most other kinds of land cover from other administrative sources, whether it's forestry or grassland or urban areas. But peatlands wasn't conveniently available to us. We used to be able to get it from a source called the National Land Cover Map, but that was last published in 2018. So we were in trouble. We could measure deductions from peatland. So we could see if a forest or a town had encroached on a peatland, but we couldn't see additions. Now you might say, how could a peatland possibly grow if it's developed over thousands of years? But it can if the land use or what's on top of it, if it's a forest on top of it and that was cleared, or if a peat was restored, which is part of a national policy. There's a nature restoration regulation which specifies a peatland there's a policy there around peatland restoration. So that's I suppose the motivation or the background. So a machine learning model was developed based on Sentinel-2 data. So that's from the Copernicus Data Space Ecosystem, or the CDSE, and it was trained on the 2018 National Land Cover Map. And that's been very good. It works well. We're able to find our peatland to a satisfactory level of accuracy. 2 of the nice things in this process is one is that it uses object-based image analysis, or OBIA. So it breaks down the satellite image into regions or blobs, so that the machine learning is applied at that level. There's about 5 million of those, or the Republic of Ireland breaks down into about 5 million individual regions based on that image analysis. And there's also spatial block cross-validation is carried out to prevent an artificially high level of autocorrelation. So that's that project. Some of the challenges, particularly for Ireland, is cloud cover. We'd love to be able to do quarterly analysis or more rather than just an annual analysis to be able to do quarterly, because when you have quarterly satellite data, you can see the change in vegetation over the course of the year, and it can be instrumental in identifying certain land cover types. We don't have a very wide array of aerial imagery or orthophotography, so from planes rather than satellites for Ireland. So certain use cases are a little bit more limited for us. But we do have this nice capability to run this analysis annually, which we're very happy about. One lesson learned here is that where the data source is common to multiple countries, as is the case with satellite data from the CDSE, it's much easier to share methodologies and to learn from colleagues and other NSIs. So that's been very nice. And the last use case or application of AI is document analysis. I only have 2 slides on this, I think, perhaps even just one. And this is motivated by the fact that was mentioned earlier that there's a large volume of documents in the public domain with a lot of potential for statistical production. So some examples, in particular, company reports, so company annual reports or quarterly reports, inspection and audit reports, documentation around intellectual property like patents and trademarks and designs is potentially a rich source of information. Archival sources, so for example, data on old censuses and planning permissions is also of interest. We're particularly interested in company annual reports. We'd like to be able to access the financial data from those, and planning permission data as well we're going after, because there's a large manual aspect to processing data on planning permissions within the CSO. So we're developing tools to streamline and improve the efficiency of that and to provide relevant and useful information sooner in the process. So what we want to do is to make a data extraction assistant which locates, pinpoints data of interest. It tabularizes where tabularization is required, and it presents that to the user for either approval or editing or saving. So that's the aim in the next few months. Okay. So this is the last part of the presentation then. This is on the ESSnet project, Eurostat funded. It's called Artificial Intelligence and Machine Learning for Official Statistics with the code AIML4OS. So this is an ESSnet project, so a project of the ESS, or European Statistical System. There's been a sequence of those over the last number of years. For example, there's been the Web Intelligence Network, the MNO Mines project, which is about mobile network operator data. There was 2 ESSnets on big data, and there was one, I think it might be still going, on smart surveys. So there's been as I say, a sequence of those. This is one of the largest, I think, if not the largest. So this is the first slide on this. This is the project by the numbers, if you like. There's 15 funded countries in the project. The total amount of funding from Eurostat is around about 4 million. It's running over 4 years. This was a photo from the launch in Wiesbaden in April in 2024. We're just past the halfway mark now, and it's going to finish in March of 2028. The project is broken into 13 work packages, which I'll describe. We are in charge of work package 1, which is project management and coordination. There are 55 separate tasks across the 13 work packages and 39 deliverables that have to be provided to Eurostat. The aim of the project, the high-level aim, is to have a comprehensive suite of resources, guidelines, methodologies, and use cases for implementing AI and machine learning and official statistics. So there's this idea that it's a one-stop shop. So if you're a statistician in the European Statistical System, that this is where you can go to find everything that you might need to get started and to implement it. But within that are a couple of sub-goals, if you like. One is to build communities around AI, machine learning, and innovation more generally. So just to develop networks among statisticians and methodologists for knowledge exchange. And that might outlast, we hope that it certainly will outlast the timeline of the project itself. There's a real emphasis on supporting the transition from prototype to production. So not just about making pilot projects and experiments, but to seeing this all the way through to statistical production and overcoming, or at least identifying, all of the challenges and obstacles that are associated with that. We want to provide working use cases that NSIs will be able to take off the shelf and implement themselves. We want to provide a sandbox for development. I'll talk a little bit more about that in a moment. Shared standards and guidelines for NSIs, and then to deliver economies of scale as well. So this is how the project is structured. As I said, there's 13 work packages. The first 6 on the left-hand side are supporting work packages. So these support sort of cross-functional or cross-cutting aspects of the project, or they support the operation of the project itself. Each work package has a number of countries. I mentioned there's 15 or 16 countries in the project. A single work package can contain as many as 10 work packages, but each has 1 or 2 lead countries that are in charge of managing it as well. So we're leading, and we're the only country in work package 1, which is coordination. So Ireland are in charge of that. The second work package is communication, which is being led by Italy. France are in charge of work package 3, which is the AIML lab. Germany are heading up work package 4, which is on state of play or ecosystem monitoring. So that's about an assessment of the different use cases of AI across Europe and the challenges and the maturity levels around that. The Netherlands and Germany are jointly leading work package 5 on standards, methodology, and implementation. So there's 3 subgroups or clusters within that around each of those. Poland are leading a work package on knowledge repository and training. So it's kind of combining all the outputs from the project into a single resource and supporting kind of knowledge exchange across the project as well. And then on the right-hand side are the use cases. And these are 7 kind of domains or topics within AI and machine learning that are thought to be really important and applicable for statistical production. So the first of those is Earth observation data, which is being led by the Netherlands. And then Germany are leading work package 8 on editing. Closely related to that is work package 9 on imputation. So they work quite closely together. They have joint meetings and so on. That's being led by Spain. Germany are leading one on text to code or text classification. There's an interesting one on work package 11, which is supply chain networks, led by the Netherlands. They are using a method from the University of Oxford. I'll just say a little bit about it quickly. What it involves is the use of inter-firm trade data, so data on trades between individual companies, so a gigantic data set. So such a data set exists in Portugal and I think also in the Netherlands. And the idea is that you would use this firm-to-firm trade data to reconstruct a supply chain network for an entire economy. So it's and you can test that in the countries where you have the granular data, and then the idea is that you try and apply it then in countries that don't. So it's just an interesting one. I wasn't aware of that kind of analysis or process before this project. Sweden are leading work package 12 on large language models, and work package 13 is synthetic data, jointly led by Italy and Austria. So the rest of this presentation, I'm just going to dive into a handful of these. I'm not going to go through all of them, just to give a little bit of an update about what's going on and some of the interesting work that's in here. So well, actually, I forgot about this slide. Before I get into that, just a little word about trying to manage a project of this scale. There's a lot of overhead around coordinating a project with 240 people, lots of countries, interconnected work packages. So we have every 6 weeks, we have meetings among the work package leads. Every second one of those, which is approximately quarterly, we have an extended one of those meetings where we have a financial review. We have a panel of reviewers, I should say, and these are experts in different domains that we've attached to different work packages. And they're a kind of a quality assurance function. So they comment on how well the work package is doing. And they also are able to provide ad hoc guidance to the work package. We have a network of observers who attend the meetings, the operational work package level meetings. So that's just our way of maintaining an awareness of what's going on across the project. And there's a huge amount of organization and infrastructure like calendar, mailing lists, SharePoint pages, LinkedIn, and so on. Okay, so getting into the work packages then, just starting with this work package 3, the AIML lab. It's providing a development environment for the whole project. That development environment is SSP Cloud, which is powered by Anixia. So the French NSI is very much involved here. They're also producing guidelines on how to set up technical infrastructure for AI and ML and how to maintain that. They had a funathon just a few weeks ago in May, and that is a non-competitive hackathon, which ran for 2 days, and people all over Europe formed teams in their own NSI and took part in this. And there was resources provided to guide you through three different projects as part of this. There was one on real estate prediction or predicting house prices. There was another project on text classification, and the last one was on satellite image analysis. So it was a really nice 2 days. This is an image from the CSOs. Well, one of the CSOs team. We had 13 people involved in it, and yeah, it was quite hats off to the French and the other people in Work Package 3 for making it a great success. Work Package 7 then is on Earth observation data. They met in, I think it was in Paris in 2024, and they looked at lots of different models and decided to pick two to pursue. So the first one is on crop type mapping. It uses a model from Statistics Poland. That model uses Sentinel-1 radar data combined with object-based image analysis. And what it does is it looks at the backscatter data or the backscatter signal from different crops, because different crops have a different backscatter signal, especially over time, depending on their growth pattern over the course of the year. And the Polish model is able to identify lots of different crops, but for the purposes of this work package, it was aggregated up to 3 crop types: winter crops, spring crops, and rapeseed. And they use the Sentinel-2 data for labeling for the ground truth. And the aim is to develop a simplified modular version of this that can be shared and tested across NSIs. So they have this model, they've aggregated it up to 3 classes, and they're testing it in different countries and regions across Europe. So this picture is from a region in Portugal, and it highlights the winter and spring crops identified using that model. The other model that Work Package 7 are pursuing is this one, which is called FLAIR COSIA. It's from IGN, which is the French Institute for Geographical Information and Forestry. And it uses this kind of transformer-based SWIN backbone as its a main model to capture these complex patterns in the high-resolution orthophotos. So this is orthophotos from planes as opposed to satellite imagery. And again, it's a similar story to the first model. They're testing it out in different countries and regions across Europe to see how it compares, how its utility compares, and how it performs. And that picture is from their meeting in Paris in November 2024 when they chose their models. Moving on then to Work Package 10 on text classification. They looked at lots of different challenges and decided to pick 5 and develop a cluster around each of those 5 challenges. So that's how it's broken down. They're looking at insufficient training data is cluster 1. Cluster 2 is around the complexity and nuances of natural language. 3 is using the hierarchical nature of classification structures. So most, if not all that I know of, classification structures are hierarchical. There's a kind of a coarser to more granular route, which would probably be used by humans who are classifying things, but they're very rarely used by machine learning models. So they're looking at some models that can acknowledge or can make use of the hierarchy of a classification. Cluster 4 is about using these in production and maintaining them in production. And number 5 is then around adapting to revisions with a strong focus on NACE 2.0 to 2.1. So that's Work Package 10. Work Package 12 met in Lisbon last year, and this is a photo from that. And they looked at 3 prototypes and they developed them over the course of a hackathon over a couple of days. The prototypes that they pursued and developed were, number 1, summarizing statistical reports. So when this tool is given a PDF of a statistical report, it's able to summarize it in different languages and attach keywords to it. Number 2 was extracting quantitative data from annual reports. And number 3 was combining large language models with web scraping to collect specific targeted pieces of information from websites. So they developed each of those to a prototype stage. A large part of this work package is also about implementation, about operating and maintaining an LLM in production. So they produce outputs in that as well. They had another hackathon just last week in Stockholm over 3 days, and I don't yet know what happened at that, but I presume that the process was pretty similar to the first one, that they identify a couple of prototypes and try to execute those over the 3 days. The last one that I'm going to talk about is Work Package 13, which is synthetic data. There's a lot of different applications for synthetic data in statistical production and in statistics. From microdata, so maybe improving access to microdata, around research and innovation, testing software, developing software. It's very good to have synthetic data, and for training purposes as well. So there's a lot of use cases being explored within this work package. There's a lot going on. They have a deliverable which they've just finished, but has not yet been published. But it should be published, I think, by the end of July or thereabouts. And yeah, there's about 6 different countries have produced use cases within this with a lot of different angles. So it's like a very busy matrix of things going on, different domains. So there's a lot of, I suppose, social sciences in here, but also enterprise statistics, different types of data, different purposes. So who is the synthetic data for? Is it for a researcher in a very tightly controlled access, or is it for the general public? They're looking at lots of different methods for generating synthetic data and also different methods for measuring the utility or the usefulness of the data. And there's a really big emphasis also on the privacy, on the non-disclosure, the confidentiality of synthetic data. There's a lot of different methods that can be used to try to uncover disclosive data from synthetic data, and they're exploring a lot of those as well. So those are some of the countries that are involved in this work package. We had the halfway point in the project just a few weeks ago. So the CSO produced an infographic on, to mark the occasion. And here it is. It talks about some of the progress in years 1 and 2, and then looking ahead to years 3 and 4. We had a town hall event a few weeks ago where we had everybody in the project got together to have an update. We had a lead meeting just before the quality conference in Croatia at the beginning of the month. And we hope to have a closing event in Dublin Castle in the first quarter of 2028. And there's still 29 deliverables to go. So 10 down, 29 to go. And that's the end of my presentation. I'm finishing up here with a couple of links to the AIML 4OS project, the one-stop shop. The first one there is our website that we're building. It has some of the recent deliverable reports. It has some of the news. It has all of the slides and presentations that we had at the quality conference. We had about 20 presentations at the quality conference in Croatia. There's a link there to our LinkedIn page, or if you want to follow updates on that, and links to the dashboard and cross, and if you wanted to sign up for our newsletter as well. So that's all from me. Happy to take any questions or indeed comments.
Thanks, Brendan. That was a lot of information. Thanks for this. I would like to open up now the floor for questions. So please, now the microphones and cameras are enabled. If you want to ask a question live, please just raise your hand. Makes it a little bit more interactive. And I see Benny from UNCTAD has his hand up, so let me hand over to Benny, please.
Thank you so much. Thank you so much for a very informative and interesting presentation. I wanted to hear your thoughts on use cases, potential use cases, where you move the AI empowerment one step closer to the respondent and use it for surveying. So even if for administrative purpose, it might not be applicable in the cause of death example, but imagine that you would have a tool at disposal for medical professionals that help them classify correctly the cause of death. And that, what I'm thinking about is trade in services, where the classification is quite, for the responding enterprise, might be complex to understand, to have something that helps them to respond informatively and accurately. Do you see any problems with that? Do you know of any use cases and thoughts about going in that direction? Thank you so much.
Yeah, thanks for your question. I think it's definitely, I would think in the same way that the correct thing to do is to move these tools closer to the point of data collection so that you improve quality and classification and things like that there rather than later on. And we'd very much like to do that. I think the problem is that you're involving more organizations and the deployment of the technology becomes more complex. So we're at the stage of getting it working under our own roof. And but absolutely, we'd love to push it closer to the respondent. I had seen the ONS doing really exciting stuff in this space where they had tools for classifying things that included the capability to provide customized questions to kind of hone in on the correct classification. It was really impressive. So we're not quite there, but definitely that's the future direction.
Yeah, thank you, Benny. Thanks, Brandon. There was one question by Gabriel here from UNSD. Gabriel, you want to come in?
Yes, thank you. Can you hear me? Yes, thank you very
Yes,
much,
please.
Alex, and thank you, Brendan, for this really inspiring presentation. It was really interesting, and I think also the step-by-step approach is also very helpful when it comes to capacity development. And maybe my question is a bit related. What kind of tool have you used for the assessment of your maturity level? There are different one out there, so just which one have you used? And the second thing is, since you are, I would say, in the coordination and management of this European initiative, how much do you also interact or reach out to other similar initiatives at global and regional level? You know that there is now this new Kigali city groups on AI that has been set up by the Statistical Commission and other similar initiatives also at regional level. Is there a mechanisms actually to keep these various initiatives informed? Thank you very much.
So I saw your first question coming in about the tool to find this AI maturity, and since I saw your question come in, I was trying to find it through my emails. I can't find the name of it. We did it in partnership with Deloitte, a consultancy group here, and if I can dig out the name of it, I'll try to send it on to you or make it available to you. In terms of coordinating with other international groups and stakeholders, it's something that we're very, very interested in, especially now for the second half of the project, the final 2 years, because the different work packages are now up and running. They're beginning to produce outputs, and now is the right time for doing that. We had some engagement with UNECE, particularly around standards, guidelines, and implementation, where I think they were doing very good work on AI readiness and the dissemination side of things, and we agreed that we would leave that alone altogether and not duplicate the work in that area, and that we would focus on GSBPM steps 4 through to 6 instead. So those kinds of conversations are really valuable, and we're very much open to them. I can't think of other examples in the last year other than the UNECE on AI readiness.
Thank you. Thank you, Brendan.
Thanks. And I see Amr has his hand up. Amr, over to you.
Thank you, Alex. I'm Amr Noor. I'm the head of the Data Innovation and Capacity Management branch, the organizer of this series. And really, on behalf of the team, I'd like to thank you, Brendan, very much for this presentation. It's been really, really informative, as it has been said. Now, I have one comment and one maybe specific question. The comment is really of a general nature a little bit, because it seems to me, and this really applies to other areas, not only to AI, but I think it's more, at least to my mind, and correct me, it's more accentuated a little bit in defining the use of AI a little bit specifically for the production cycle of official data. And that's that the problem definition seems to me key, all right, in optimizing the use of AI. You kind of presented to us a lot of use cases, all right, some of them related to data generation, data quality, data analysis, responding to policy. And it's really, there is really almost an infinite potential and possibilities of use of AI. And I think how you go about defining your problem, all right, is key, especially for NSOs with limited capacity and NSOs in the South and so on. And you kind of indicated a little bit your governance structures, but if you kind of would like to share a little bit with us, a little bit more about kind of this problem definition, all right, and the selection of your use cases, all right, that would be great insight. The second question is really about the technical infrastructure to do all this, all right, and what investment, like all this requires obviously a lot of investment, all right, especially for data processing and data storage and so on. And has your office went into an upgrade of its technical infrastructure, a great investment boost, or what? How did you go about this to cope with this AI use, especially in the production cycle? Thank you.
Yeah, I think there's two very good comments. The first one about the problem definition, I think, is a really good one. It's about finding the right problems and going after the right problems, and because, as you say, there's an infinite number of things that could be pursued, and you don't want to end up in a black hole where you, I don't know, chased after some project because it was shiny and it looked interesting, but didn't provide any material benefit to users or to policymakers. So I think that it was always the case that some kind of an assessment of cost benefit needed to be carried out. But I think particularly now with AI, that so much is possible that you have to be a bit more strategic in what you choose to go after. That was the case with document analysis. Just speaking on reflection of one project with document analysis, we're at a very early stage of it. But I suppose it was important to us that we worked on something that tied up with our existing capabilities, built on what we were already good at, that we developed capability that's redeployable, that we don't just have a one-shot kind of skill that is used once and then is never applicable again. Trying to find parts of the office that are not struggling but have a large manual aspect to the process, because there's somewhere where you can hopefully make improvements. So those are some of the kind of things that we think about when we're trying to decide what to do. I suppose also what has worked in other statistical offices as well, to try and build on their successes. In terms of technical infrastructure, I'm afraid I'm not an expert in technical infrastructure and the kinds of stacks and things that are involved there. We are in the middle or towards the maybe second half of a transition from SAS to R, so that's occupied a lot of our I suppose our efforts around technology in the last number of years, and that's opened up a lot to us as well in terms of data science and things that can be done. And we're looking at building up and investing in our technology in the coming years to make better use of AI. But I can't say anything more concrete about what kind of infrastructure or the costs and so on about that, I'm afraid.
Thank you. I just want to ask you two more quick questions and then we need to wrap up because we're already slightly over time. So there was a question by In-Kyung Choi in the chat from ECE. So basically two questions. So the death cause classifier and the NACE classifier system, were they using the same software or is it similar software? And then there was a question whether you use the performance of these classifiers to retrain the model.
Yeah, okay. So we're very proudly recycling the application from the cause of death, repurposing it for NACE, just so that we don't have this a phrase I heard yesterday was application creep or application sprawl, just that you end up with too many different applications in an organization. So we try to kind of keep it modular and reuse the same things. And then do you monitor the performance of these classifiers? Very interesting and topical for ourselves. We are able to monitor the use of them. We are able to see, day by day how many users are logging and using it. And we are just beginning a process of looking at what decisions were made using the application versus when it wasn't used, because I think that's going to be very important to see, is it actually improving the speed that they do things? Is it suggesting codes that they wouldn't otherwise have used? Or is it kind of over streamlining things into specific codes? So we need to look at that to do that, but that work is just beginning. And what's the plan with retraining the ML models? Yeah, new data is becoming available all the time. We don't have a systematic approach to that yet, I'm afraid. We're even still, even based on the existing data that we have, we're looking at retraining models all the time to see if we can improve their performance.
Okay, thank you, Brendan. There are still a couple of comments in the chat you might want to have a look at, but now I would like to encourage everyone to switch on the cameras and also the microphones and maybe give Brendan a big round of applause if that is possible. So please turn on your cameras. Thank you.
Thanks very much, everybody. I really enjoyed it. Thanks for all the questions.
Thanks, everyone. So I have shared also in the meeting chat the link to the last webinar in this AI series, which will be next week already, 30th of June, using AI for dissemination of official statistics. And you also see there the links to the recordings of the previous webinars in this series. So thank you everyone for joining today, and have a great rest of your day. Thanks again, Brendan, for doing the presentation. Thanks.
No problem. All the best. Bye-bye.
Thank you, Alex. Thanks.